Hello guys, in this video we are going to discuss the solution of the problem pairs with difference k. So let us look at the problem statement. The problem statement says given an array ARR of positive integers, find the number of pairs of integers whose difference equals to given number k. So for instance, if this is the array which is given to us and the value of k equals to 3, then in such case there are two pairs which are possible whose difference is equals to 3. And those two pairs are 1, 4 and 5, 2. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is, first what we are going to do is we are going to sort the array, and then we are going to take two counters I and j and we are going to set it to 0. If the absolute difference between ARRI and ARRJ is less than k, and since the array is sorted, in order for this difference to become equals to k, we have to increase j. Similarly, if the difference between ARRI and ARRJ is greater than k, and our objective is to make this difference equals to k, so in such case we just have to increase the value of I. And in this way, either by increasing the value of j or I, we will be able to make the difference equals to k. When the difference is equals to k, in such case, we just have to count the number of pairs. So that's the general idea behind solving this problem, folks. Now let us take some example in order to understand this. So let us say the array which is given to us is this, and the value of k is equals to 3. So the first thing which we are going to do is we are going to sort this array. So after sorting, the array will look something like this. So once we have sorted the array, what we are going to do is we are going to take two counters I and j, and initially we are going to set this value equals to 0. Then we are going to compute the difference between ARR I and j. So this is 1 minus 1, which is equals to 0. Since the difference is 0 and this 0 is less than 3 and our objective is to make difference equals to 3, in order to achieve that we are going to increase the value of j. So let us increase the value of j. So j becomes equals to 1, and again let us compute the difference. So this time the difference is 1 minus 2, which is equals to 1. And again, since 1 is less than 3, we are going to increase the value of j. So let us again increase the value of j. So now j becomes equals to 2 and the difference is 1 minus 3, which is equals to 2. Again, 2 is less than 3, because of which we are going to increase the value of j. So j becomes equals to 3 and this time the difference is 1 minus 4, which is equals to 3. So as you can see, this is my first pair, because of which there will be an answer variable and we are going to increase that answer variable to 1. Now once we have obtained this value, all we have to do is we have to increase the value of I and j. So now the value of I becomes equals to 1 and the value of j becomes equals to 4. Again, we are going to compute the difference. So the difference is 2 minus 5, which is equals to 3. Since this is equals to k, because of which we are going to update our answer, and now the answer becomes equals to 2. And in this way, if you see, we have reached the end of the array. So we have iterated through all the elements of the array, and the number of pairs whose difference is equals to 3 is 2, and this is what we are going to return. So folks, this is the core logic. Now there are two more cases over here. Let us discuss those cases and then we will discuss the pseudocode. So the first case which we are going to discuss is the case where duplicates are present. So what do I mean by this is, let us say the sorted array which is given to us is something like this, and the value of k is equals to 3. So it is the same example which we have just discussed. It is just that now there are multiple entries of 1 and there are multiple entries of 2. So if you recall from our previous discussion, using the same logic, we will come to a position where I is equals to 0 and j is equals to 7, which simply means ARRI is equals to 1 and ARRJ, which is equals to 7, is equals to 4. In such case, as we can see, the difference between, or rather the absolute difference between ARRI and ARRJ is equals to 1 minus 4, which is equals to 3. So this value is equals to k now. Now we have to count the number of pairs. So as you can see, the first pair which we have observed is 1, 4. Now we have multiple entries of 1 in the array, because of which 1 comma 4 should occur for 3 times, which is essentially this one pairing with 4, this one again pairing with 4, and this one is pairing with 4. In this way, we will obtain this 3 pairs. So in order to accommodate this in our logic, what we are going to do is, once we have realized that the difference between ARRI and ARRJ is equals to k, then what we are going to do is we are going to count the frequency of element ARRI, and similarly we are going to count the frequency of element ARRJ as well. Now let us assume in our previous example, frequency of element ARRI is equals to 3 and frequency of element ARRJ is equals to 1. So the number of pairs which we will get is essentially equals to 1 into 3, which is equals to 3, and that is the number of pair we have obtained. Similarly, let us assume that the frequency of element ARRI is equals to 3 and the frequency of element ARRJ, let us say that this value is equals to 4. Then in such case, the number of pairs will be equals to 3 into 4, which will be equals to 12. So folks, this is one concept which I wanted to explain, which is once we have obtained a case where the difference between ith and jth element is equals to k, then in such case, rather than just increasing the value of answer by 1, what we are going to do is we are going to count the frequency of element ARRI and ARRJ. If the frequency of element ARRI and ARRJ, let us say this value is equals to 1, then the number of pairs is equals to 1. If the frequency of ARRI equals to 3 and frequency of ARRJ equals to 1, then the number of pairs will be given by frequency of ith and jth. In this case, this is equals to 1 into 3, which is equals to 3. Similarly, if the frequency of ith and jth element is 3 and 4, then the number of pairs will be given by 3 into 4, which is equals to 12. So folks, this is the first case. Now let us discuss the second case as well. And this is the case where duplicates are present and value of k equals to 0. So to understand this case, let us say the array which is given to us is something like this and the value of k is equals to 0. Then using the logic which we have discussed, first we want to find out the value of I and j where the difference between ith and jth is equals to k. So in this case, the value of I and j will be equals to 0. And as we can see, the difference between ith and jth character is 0. ARRI minus ARRJ is equals to 0. Now once we have found out our ith and jth character, then as we have discussed in case 1, we are going to count the frequency of ith and jth element. In this case, the frequency of ith and jth element is equal, which is equals to 3. Now we need to count the number of pairs over here. So the number of pairs over here will be given by frequency of ith element into frequency of ith element minus 1 divided by 2. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to count the number of pairs with k and an array is given to us and the value of k is given to us. So for this, we are going to take I, j an answer and the initial value of these values is equals to 0. Then we are going to iterate on the elements of the array. So while j is less than len of array, and we are going to check if absolute difference between ith and jth element is less than k. In such case, we just have to increase our j by 1. Else, if the absolute difference between ith and jth element is greater than k, then in such case, we have to increase the value of I by 1. Otherwise, we have to count the number of pairs. So let us count the number of pairs. So for that, let us have our count 1 and count 2. Initial value of this count 1 and count 2 equals to 0. And then let's have element 1 which is equals to ARRI and element 2 which is equals to ARRJ. And then we are going to count the frequency of ith and jth element. So let us do that. While I is less than len of array and ARRI equals to element 1. In such case, all we have to do is we just have to increase our count 1 by 1 and we need to increase our I by 1. Similarly, let us count the frequency of arrj while j is less than length of array and arrj equals to element 2. In such case, let us increase our count 2 by 1 and let us increase j by 1. And in this way, we have counted the frequency of element arri and arrj. Now, once we have counted the frequency, we just have to increase our answer appropriately. So let us do that. So for that, let us say if this is case 2. So for case 2, element 1 should be equals to element 2. If this is case 2, then in such case, answer will be increased by count 1 into count 1 minus 1 divided by 2. And if this is case 1, then in such case, answer will be increased by count 1 into count 2. And in this way, we will be able to count the number of pairs, and towards the end, we just have to return answer. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first, let us look at the Python implementation. Over here, we have answer I and j, and we are setting the values equals to 0, and then we are sorting the array. Folks, in the pseudocode, I think I forgot to sort the array, but sorting is needed. So we are going to sort the array, and then we are going to iterate on the elements of the array. If the absolute difference is less than k, then in such case, let us increase j by 1. Otherwise, if the absolute difference is greater than k, then we are going to increase I by 1. Otherwise, we are going to count the number of pairs, and towards the end, we are going to return answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. Over here we are sorting the array, and then we are iterating on the elements of the array. If the absolute difference is less than k, then increase j by 1. If the absolute difference is greater than k, then let us increase I by 1. And if the absolute difference is equals to k, then let us count the number of pairs, and towards the end, let us return answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.